Summary of ISO 14971. So, ISO 14971 is the international standard for risk management of medical devices, providing a structured framework for identifying, evaluating, controlling, and monitoring risk all the way throughout their life cycle. So, there's two things that I want to point out to you there. The one is that it's specific to medical devices. And what does that mean when we apply risk management? Well, that means that when we apply risk management, the risks that we're going to end up talking about are going to be risks that relate to harming patients, operators, and the environment it's used in. So you still consider stuff like fire hazards, but you don't consider things that are like business risks because you can, of course, apply risk management to business and then you have like financial and schedule risks. But here, of course, we're talking about medical devices, hence the standard adapts risk management principles to medical devices. So we narrow our focus of the word risk to just these three kind of key areas. And then when we talk about the term life cycle, the term life cycle is meant to try and incorporate the time from conception of the actual product to design to development to when you start production to post production. And then once you go to post production, you have things like installation, servicing, maintenance, and then eventually you arrive where the device is disposed of. So it's conception all the way to dispose. You may wonder what exactly do we mean by risk, and we've pretty much alluded to it there, but there is in fact a definition in the standard, and what that definition is it is a combination of the probability of harm, which is also a defined term, so I'll write harm in small capital, and the severity, which is also a defined term, so it's written in small capital, severity of that harm. And that is taken directly from the standard itself, so I put down ISO 14971. So when we look at risk, we always try and describe it in terms of both the probability and, of course, the severity of that harm. And when we talk about harm, we've narrowed the scope of the word harm, and harm has its own definition, and it is basically those three elements. It is injury or damage to the health of people. When we say people, generally we're talking about the users of the device, so we're talking about the operator and patient, and there could be multiple operators and multiple patients, or damage to the property or the environment. So the word environment there you can generally think of as the setting where the device is used. And when we're talking about damage to property or the environment, you consider things like fire, you can consider things like substances leaking from a device, and you can consider things like excessive acoustic noise can be a risk. And of course, this definition also comes from ISO 14971. When we think about injury, you'll note there that there was an earlier version of ISO 14971 prior to the 2019 version, and they used to state that harm was physical injury, and then they changed it to just injury, and that was meant to imply that harm is both physical or mental. So we should try and not only mitigate physical injury, but also things like stress. And of course, you can imagine an AED, it can be very stressful for the operator when using this device on a patient. So we're meant to try apply risk management to mitigate the risk of mental stress on this individual as well. So what shall we do next? We shall consider in the patient setting below, so this is the patient setting of our actual AED, what exactly do we mean by risk? And we're going to throw a few examples at you. So the first thing that we might consider here is accidental shock to the operator. I'm going to constantly use the words operator to refer to the person who is using the medical device, and the word patient to refer to the person who is receiving treatment, simply because those are the words that are commonly referred to in IEC 60601, which is a very big standard in medical devices for electrical medical systems. So I'm just going to align myself with its terminology. Now, when we consider here accidental shock to the operator, we can think of that as a risk, and that, of course, is concerning harm to that of people, the operator using the device. Another one that we might consider here is accidental shock to the patient. Another one we can consider is misuse. So we might consider misuse in terms of it's used to treat a person who fainted maybe from heat stroke or something. Their heart is completely fine. They don't need to be treated by an AED. Another one that we might consider over here is delayed use. There's only a limited time this person has with their heart not working before they'll start to receive serious injury or brain injury. And so if the operator stumbles, it really starts to diminish the chances of this poor chap here having a positive outcome. And then we might consider just a user panics. It's a very stressful situation. And or the device fails. Maybe you go to use the device, but the battery is dead. And then of course it can't be used. Another one that we might consider is just normal use. So it's used as normal, but of course there's still risks of pain that this individual is going to experience. And of course, there's the stress that this individual is going to experience. So there's still risks associated with normal use. And of course, another one that we might consider, I'll put it here, there's a fire risk. And that's because this device is an electronic device inside a mechanical assembly. That mechanical assembly is likely going to be made of plastic. So it is reasonably foreseeable that the internal electronics, some failure could result in a fire and then the plastic case goes on fire, especially when you consider a defibrillator has hazardous voltages inside it. And you could get stuff like arcing. Then, of course, we're going to see fire as a risk, and that will be a risk to the environment. So these we can all consider our risks. Now, when it comes to ISO 14971, identifying risks really is just the start of the whole process, and it's not the big picture. The big picture is how do we mitigate these risks? How do we implement risk control measures to reduce these risks from causing harms to the people or the environment? What we can do there is we'll basically look at each one, and the reason that we identify the risk of accidental shock to the operator, therefore we're going to implement risk control measures of having an insulated case and cables. Okay, and if we have a fire, therefore we're going to implement a risk control measure of use plastics and PCB assemblies with flammability ratings. What's another one we have here? Accidental shock to the patient. So then, of course, we might implement a risk control measure like there's now a shock button, and there might also be arrhythmia detection. So those are two kind of separate risk control measures. The AED will look at the patient's heart signal via the pads and detect is it a suitable condition to apply the actual defibrillator pulses. And if it does, it'll flash the button on and off, and that should signal to the operator with voice prompts as well to actually administer the shock. So there's just controls are placed to prevent this risk from occurring. What else do we have here? Misuse used to treat a person who fainted. So that one again, we could look at the arrhythmia detection, that if they have a normal, their heart is beating as normal, but the operator fails to detect their pulse, the machine will not administer defibrillator shocks. And what else do we have? Our next one, normal use, pain and stress, or delayed use. Then we can consider the voice prompts are there to help the person out. And we might also consider here just any information for safety, which is like instructions on the pads or any other instructions. You might try put instructions on the actual enclosure itself. You could also put instructions in the user manual, but the good Lord knows in this panic, stressful situation, this individual may not have time to read a user manual. So I'll just put up here as well information for safety. Okay, so that's kind of the process in a nutshell. Identify risks, introduce suitable risk control measures. The big emphasis really on ISO 14971 is not only introducing risk control measures, but you have to verify that they are in fact effective. And that is something that we'll explore in more detail in later chapters. But hopefully, just this kind of short and sweet story of identify risks and implement risk controls can really show you how risk management can be used with our overall goal to always make more safe and effective devices. And as we will kind of see throughout, risk management is basically just the structured procedure that we apply to achieve this overall goal of safe and effective devices. So our other note here is just basically in ISO 14971, we apply the principles of risk management to mitigate risks, all with the aim of making safe devices. Safety being freedom from unacceptable risk. Okay, so I'll conclude that summary there, and I shall see you in the next lesson.